Bismillahirrahmanirrahim. It's me, Kashif Arif, and my group member is Kamran Mehmood. Our topic is about catalyst. Main contents of our topic is what is catalyst, how does it work, some terminologies, types of catalyst, and the last thermodynamics. Now, what is catalyst? Catalysts are those substances which, when added to a reaction, they increase the rate of reaction by providing an alternate reaction pathway with the lower activation energy. And catalysts do not chemically change while at the end of the reaction. Now, how a catalyst works, how it helps the substrate to convert it into products. For a reaction to occur, molecules must collide. The frequency of the collisions affects the rate of the reaction. The frequency can be changed by increasing or decreasing the concentrations of the reactants, and by changing the temperature it changes the velocities of the molecules. But even when molecules collide, they do not all react. In order to react, the two molecules must be oriented in just the right way. Molecules must also have enough energy for the reaction to occur. Some minimum energy is needed because existing bonds must be broken and new bonds must be formed. When new bond form, transition complex is formed. So, what is transition complex? The point in the reaction at which this reconstruction is occurring is called the transition state or activated complex. The energy needed to reach the transition state is called the activation energy, and it is represented as EA or delta G. It is also defined as the energy required to overcome the reaction barrier. Activation energy also determines how fast a reaction occurs. The higher activation barrier, the slower the reaction rate. Here in the figure, the peak represents the activation barrier. Now, there are two types of catalysts. One is organic catalysts and the other one is inorganic catalysts. So, what are organic catalysts? The organic catalysts are those catalysts which are used to catalyze the reactant which are organic in nature. Organic catalysts are also called enzymes. Enzymes. Enzymes are proteins that catalyze biochemical reactions. Enzymes, they consist of cofactors and coenzymes. Now, what are cofactors? Some enzymes need any additional components to show full activity. This additional component is called cofactor. Cofactors are non-protein molecules to be bound for activity, and they can be either inorganic, for example metal ions and iron sulfur clusters, or organic compounds, for example flavin. Now, what are prosthetic groups and coenzymes? The groups which are tightly bound to an enzyme is called prosthetic groups, and the groups which are released from the enzyme's active site during the reaction is called coenzymes. Coenzymes, they are small organic molecules that can be loosely or tightly bound to an enzyme. Tightly bound coenzymes can be called allosteric groups. Coenzymes transport chemical groups from one enzyme to another enzyme.
Assalamu alaikum. My name is Kamran Mehmood and I am going to tell you about working of catalyst. In enzymatic reaction, the molecules at the beginning of the process are called substrate and they are converted into different molecules called the products. Like all catalyst, enzymes work by lowering the activation energy for a reaction, thus dramatically increase the rate of reaction. As a result, products are formed faster and reaction reaches, reaches their equilibrium state more rapidly. Most enzymes are much larger than the substrate they act on, and only a small portion of enzymes is directly involved in catalysis. The region that contain these catalytic residues binds the substrate and then carries out the reaction is known as active sites. Enzymes can also contain sites that binds cofactors which are needed for catalysis, and some enzymes also have binding sites for small molecules which are often direct or indirect products or substrate of the reaction catalyzed. The binding can serve to increase or decrease the enzyme's activity. Now I will tell you about how a catalyst react are used to minimize the activation energy. Enzymes can act in several ways, all of which is used to lower the activation energy. Lowering the activation energy by creating an environment in which the transition state is stabilized, steering the shape of substrate by binding the transition state conformation of the substrate product molecules. The enzyme distorts the binding substrate into their transition state form, thereby reducing the amount of energy required to complete the transition state. This is the first mechanism which is used to reduce the activation energy. The other mechanism which is used to lower the activation energy is lowering the activation energy of the transition state but without distorting the substrate by creating an environment with the opposite charge distribution to that of transition state, providing an alternating pathway, for example, temporarily reacting with the substrate to form an intermediate ES complex which would be impossible in the absence of enzymes. This is the other mechanism which is used to lower the activation energy. Increase in temperature also speed up the reaction, but this increase in temperature is limited because high temperature affects the efficiency of the enzymes. Thus, temperature increase helps the enzymes functions and develop the end products even faster. Now, to understand that how a catalyst reduce the activation energy is to understand the origin of reducing activation energy. This requires one to how find out how the enzymes can stabilize its transition state more than the transition state of an uncatalyzed reaction. Apparently, the most effective way for reaching large stabilization is to use the electrostatic effect, in particular when having a relatively fixed polar environment that is oriented towards the charge distribution of the transition state. Such an environment does not exist in uncatalyzed reaction. Now, what is thermodynamics of catalysis? Enzymes do not alter the position of the chemical equilibrium of a reaction. Usually, in the presence of enzymes, the reaction runs in the same direction as it would without the enzymes, just more quickly. However, in the absence of enzymes, other possible uncatalyzed spontaneous reactions might lead to different products because in those conditions, this different products is formed faster. Enzymes catalyze the forward and the backward reaction equally. They do not alter the equilibrium itself but only the speed at which it is reached. The graph shows that if the peak is higher then the reaction is uncatalyzed, and for catalyzed reaction the peak is low and reaction go faster. Now the other type of catalyst is inorganic catalyst. The type this type of catalyst is catalyze the reaction in which maybe inorganic substance or organic substance are present, but These catalysts are inorganic in nature. Now, the working of inorganic catalyst. One or more of the reactant are adsorbed on the surface of the catalyst at active sites. Adsorption is where something sticks to a surface. An active site is a part of the surface which is particularly good at absorbing things and help them to react. There is some sorts of interactions between the surface of catalyst and the reactant molecule which makes them more reactive. This might involve an actual reaction with the surface and some weakening of the bonds in the attached molecules. At this stage, both of the reactant molecules might be attached to the surface, or one might be attached or hit by the other, moving freely in the gas or liquid. The product molecules are desorbed. Desorption simply means that the product molecules break away. This leaves the active sites available for a new set of molecules to attach and react. A good catalyst need to adsorb the reactant molecules strongly enough for them to react, but not so strongly that the product's molecules stick more and less permanently to the surface. Now, some types of catalyst which increase or decrease the activity of catalyst. The substance which increase the catalyst activity is called promoter, and the enzymes which decrease the activity of catalyst is called the inhibitors. Autocatalyst. A single chemical reaction is said to have undergone autocatalysis or be autocatalytic if the reactant product itself is the catalyst for that reaction. A set of chemical reactions can be said to have completely autocatalytic if a number of those reactions produce as reaction products catalyst for enough of the other reactions that the entire set of chemical reaction is self-sustaining given an input of energy and food molecules. Now, the conclusion of our topic is if we use catalyst, we get products in short time which better for us in accordance to time. That's all.